Hey guys, thanks for starting to watch the third part of the review book. Stay with this one right until the end, and you'll be surprised with a little bonus. Kind of a reward for sticking through the dry stuff.
God blimey, son. If there's one thing I don't need to know about is the bloody weather. I've known the weather since 1942.
Chapter 3 Weather Information. Private or exam guide. Okay, let's turn the page. Okay, children, let's begin. A. Nature of the atmosphere. Dun, dun, dun. Number 1. State the general characteristics in regard to the flow of an air around and... Oh, let me start that again because I totally balls that up. State the general characteristics in regard to the flow of air around high and low pressure systems in the northern hemisphere. Low pressure inward, upward, and counterclockwise. High pressure outward, downward, clockwise. Number 2. If your route of flight takes you towards a low pressure system in general, what kind of weather can you expect? Bloody weather, that's what. What if you were flying towards a high pressure system? A low pressure system is characterized by a rise in air, which is conducive to cloudiness, precipitation, i.e., rain, and bad weather. A high pressure system is an area of descending air which tends to favor dissipation of cloudiness and good weather. Number 3. Describe the different types of fronts. Cold front occurs when a mass of cold, dense, and stable air advances and replaces a body of warm air. Occluded front, I don't know if I pronounced that right, OCCLUDED, occluded front. A frontal occlusion occurs when a fast-moving cold front catches up with a slow-moving warm front. Two types: cold front occlusion and a warm front occlusion. Oh, so basically a thunderstorm. Warm front. The boundary area formed when a warm air mass contacts and flows over a colder air mass. Stationary front. When the forces of two air masses are relatively equal, the boundary or front that separates them remains stationary and influences the local weather for days. The weather is typically a mixture of both warm and cold fronts. Normally, if you're living in the state of Florida, you don't really have to worry about weather too much because it's normally just sunny, except for the hurricanes and tornadoes and stuff like that. But in the northern hemisphere, you got all the frost, cold, and you get thunderstorms, hurricanes, and everything. So it's good to know. Number 4. Oh, pardon me. I got myself a drink here because my throat's getting dry. I've done a lot of recording today. Excuse me. Number 4. What are the general characteristics of the weather What are the general characteristics of the weather a pilot would encounter when operating near a cold front and a warm front? A cold front, you would expect rain, showers, and misty. Warm front is just like spring, summer, warm. Warm front, Florida. Cold front, Pennsylvania. Cold front. As the front passes, expected the weather can include towering cumulus and cumulonimbus. I know the word. I know what it means. I can never pronounce that word. Cumulonimbus. Sounds like a broom from Harry Potter. Cumulonimbus. Pronounce it how it's pronounced. I can't say that because this video will get taken down because it's CUM, so that's not allowed. cumulonimbus. Heavy rain accompanied by lightning, thunder, and or hail. Tornadoes possible during passage. Poor visibility, winds, variable and gusting temperature, dew point, and barometric pressure drop rapidly. Warm front. As the front passes, expected weather can include straight-form clouds, drizzle, low ceilings, and poor visibility. Variable winds, rise in temperature. Note: the weather associated with a front depends on the amount of moisture available, the degree of stability of the air that is forced upward, the slope of the front, of the speed of the frontal movement, and upward the wind slow. Yeah, if you haven't noticed, if it's raining and you don't want to get wet, the best thing to do is walk, because if you run, you're only going to get wet quicker, because you increase the pressure and rain. You actually get wet more and faster if you run to your car, if you're leaving work. The best thing that you can do is just walk. You won't get as wet when you're walking. This was actually proven on Mythbusters, by the way. Absolutely true. Number 5. What is a trough? T-R-O-U-G-H. A trough, also called a trough line, is an elongated area of relatively low atmospheric pressure. At the surface, when air converges into a low, it cannot go outward against the pressure gradient, nor can it go downward into the ground. It must go upward. Therefore, a low or trough is an area of rising air. Rising air is conducive to cloudiness and precipitation, hence the general association of low pressure and bad weather. 6. What is a ridge? Same as the bridge of your nose. A ridge, also called a ridge line, is an elongated area of relatively high atmospheric pressure. Air moving out of a high or ridge depletes the quantity of air. Therefore, these are areas descending air. Descending air favors dissipation of cloudiness, hence the association of high pressure and good weather. 7. What are the standard temperature and pressure values for sea level? 15 degrees Celsius and 29.92 Hg. Yeah, that's, if you ever notice and explain stuff like that, that's the standard altimeter setting 299902. If you use the standard weather, they use sea level. So if you got your E6B and you're trying to calculate magnetic variance and stuff like that, and that's how you do. What are isobars? An isobar is a line on a weather chart which connects areas of equal and constant barometric pressure. 9. Dinah. Shika. If the isobars are relatively close together on a surface weather chart or a constant pressure chart, what information will this provide? This spacing of isobars on these charts defines how steep or shallow a pressure gradient is. When isobars are spaced very close together, a steep pressure gradient exists, which indicates higher wind speeds. A shallow pressure gradient isobars not close together usually means wind speeds will be less. Number 10. What causes the winds aloft to flow parallel to the isobars? The Coriolis force. Coriolis. 11. Why do surface winds generally flow across the isobars at an angle, i.e. surface friction? Number 12. At what rate does atmospheric pressure decrease and increase in altitude? Oh yeah, that's the 1 inch heading per 1,000 feet. Number 13. What does dew point mean? Dew point is the temperature to which a sample of air must be cooled to attain the state of saturation. When the temperature and dew point are close together within 5 degrees, what type of weather is likely? Visible moisture in the form of clouds, dew, or fog. Also, these are ideal conditions for carburetor icing. Oh, yeah. I remember what that is. 15. What factor primarily determines the type of vertical extent of clouds? The stability of the atmosphere. 16. Explain the difference between the stable atmosphere and an unstable atmosphere. Why is the stability of the atmosphere important? The stability of the atmosphere depends on its ability to resist vertical motion. A stable atmosphere makes vertical movement difficult, and small vertical disturbances dampen out and disappear. In an unstable atmosphere, small vertical air movements tend to become larger, resulting in turbulent airflow. And convective activity instability can lead to significant turbulence, extensive vertical clouds, and severe weather. 17. List the effects of stable and unstable air on clouds, turbulence, precipitation, and visibility. Clouds stratiform. Unstable is cumulative form. Turbulence, the stable version, is smooth. Unstable is rough. Precipitation, stable, steady. Unstable, showery. Visibility, fair to poor, is stable. Unstable, good. Number 18. When significant precipitation is occurring at the surface, how thick can you expect the clouds to be? Significant precipitation usually requires clouds to be at least 4,000 feet thick. The heavier the precipitation, the thicker the clouds are likely to be. 19. During your pre-flight planning, what type of meteorological information should you be aware of with respect to icing? A. Location of fronts. A front's location, type, speed, and direction of movement. Cloud layers. The location of cloud bases on and tops, which is valuable when determining if you will be able to climb above icing layers or descend beneath those layers into warmer air. Reference PIREPs and area forecast. Oh, PIREPs, those are the ones, like if you got pilots that are already in the air, the best forecasters are actual pilots doing a weather report. If they got a lot of time on their hands, they can submit a report, say, hey, it's raining here, oh, there's frost here. And Meta's updated to reflect that, because every single weather forecast is outdated the moment is out of date the moment it's posted. It's reporting on stuff that's already happened, that's already is, not what it's going to be. They can predict. They have a predicted forecast, but it's never it can change. So that's what the point of the PIREPs are. C. Freezing level. S. Important when determining how to avoid icing and how to exit icing conditions if accidentally encountered. Air temperature and pressure. Icing tends to be found in low pressure areas and at temperatures at or around freezing. What is the definition of the term freezing level, and how can you determine where that level is? The freezing level is the lowest altitude in the atmosphere over a given location, at which the air temperature reaches 0 degrees Celsius. It's possible to have multiple freezing layers when a temperature inversion occurs above the defined freezing level. A pilot can use icing products, CIP, and and forecast icing products, FIP, as well as freezing level graphics charts to determine the approximate freezing level. Because, yeah, frost is a pilot's worst enemy. Probably more so than fire, from what I gather, because ice can kill just as bad as fire. Other potential sources of icing information are area forecast, PIREBs, AirMets, and SIGMETs. Surface analysis charts, low-level significant weather charts, and winds and temperature aloft for air temperature and altitude. 21. What conditions are necessary for structural icing to occur? Visible moisture and below freezing temperatures at the point of moisture strikes the aircraft. 22. Name the main types of icing an aircraft may encounter in flight: structural induction system and instrumental icing. 23. Name the 3 types of structural icing that may occur in flight: clear ice forms after initial impact when the remaining liquid portion of the drops flows out over the aircraft surface, gradually freezing as a smooth sheet of solid ice. So, like I said, if you're in Florida, you never have to worry about ice and stuff like that. But since I'm up in PA, it's important to know. Rime ice forms when drops are small, such as those stratified clouds or light drizzle. The liquid portion remaining after initial impact freezes rapidly before the drop has time to spread out over the aircraft surface. Continued. Mixed ice forms when drops vary in size or when liquid drops are intermingled with snow or ice particles. The ice particles become embedded in clear ice, building a very rough accumulation. 24. What action is recommended if you inadvertently encounter icing conditions? The first course of action should be to leave the area of visible moisture. This might mean descending to an altitude below the cloud bases, climbing to an altitude above the cloud tops, or turning to a different course. Number 25. Is frost considered to be hazardous to flight? Why? Yes. Because while most frost does not change the basic aerodynamic shape of the ring, the roughness of its surface spoils the smooth flow of air, thus causing a slowing of the airflow. This slowing of the air causes early airflow separation, resulting in a loss of lift. Even a small amount of frost or on airfoils may prevent an aircraft from becoming airborne at normal takeoff speed. It is also possible that once airborne, an aircraft could have insufficient margin of airspeed above stall, so that moderate gusts or alternative flight could produce incipient or complete stalling. Yeah, because Isaac Newton's force equal and opposite has an opposite reaction. There's gravity keeping the plane close to the earth. You got the wind force pushing the plane up, and you've got all the P factors and stuff like that. 26. What factors must be present for a thunderstorm to form? A. Sufficient water vapor. B. An unstable lapse rate. C. An initial upward boost lifting to start the storm process in motion. 27. What are the 3 stages of a thunderstorm? A cumulus stage, updrafts cause raindrops to increase in size. Mature stage, rain at Earth's surface. It falls through or immediately beside the updrafts. Lightning, perhaps whirl clouds. And the dissipating stage, downward drafts and rain begin to dissipate. 28. What is a temperature inversion? An inversion is an increase in temperature with rate, a reversal of the normal decrease with height. An inversion aloft permits warm rain to fall through cold air below. Temperature in the cold air can be critical to icing. A ground-based inversion favors poor visibility by trapping fog, smoke, and other restrictions into low levels of the atmosphere. The air is stable with little or no turbulence. 29. State two basic ways the fog may form: cooling air to the dew point, adding moisture to the air near the ground. 30. Name several types of fog. A. Radiation fog. B. Advection fog. C. Upslope fog. D. Frontal fog or precipitation-induced fog. Or E. Steam fog. 31. What causes radiation fog to form? The ground cools the adjacent air to the dew point on calm, clear nights. 32. What is advection fog and where is it most likely to form? Advection fog results from the transport of warm, humid air over a cold surface. A pilot can expect advection fog to form primarily along coastal areas during the winter. Unlike radiation fog, it may occur with winds, cloudy skies over a wide geographic area at any time of the day or night. What is upslope fog? Upslope fog forms as a result of moist, stable air being cooled as it moves upsloping terrain. Once the upslope wind ceases, the fog dissipates. Upslope fog is often quite dense and extends to high altitudes. 34. Define the term wind shear and state the areas in which it is likely to occur. Wind shear is defined as the rate of change of wind velocity, direction, and or speed per unit distance, conventionally expressed as vertical or horizontal wind shear. It may occur at any level in the atmosphere, but three areas are of special concern. A. Wind shear with low level temperature inversion. B. Wind shear in a frontal zone or thunderstorm. C. Clear air turbulence or CAT at high levels associated with a jet stream or strong circulation. 35. Why is wind shear an operational concern to pilots? Wind shear is an operational concern because unexpected changes in wind speed and direction can be potentially very hazardous to aircraft operations at low altitudes, on approach to and departing from airports. What types of weather information will you examine to determine if wind shear conditions might affect your flight? A. Terminal forecast. Any mention of low-level wind shear or the possibility of severe thunderstorms, heavy rain, showers, hail, and wind gusts suggest the potential for LLWS and microbursts. B. Metas. Stay tuned to after this because there might be a little of a bonus for you, and you'll get to see what metas are. Inspect for any indication of thunderstorms, rains, showers, or blowing dust. Additional signs such as a warming trend, gusty winds, cumulus nimbus clouds. See, that one I can do. Cumulus nimbus clouds, etc. should be noted. Severe weather watch reports SIGMETs and convective SIGMETs. Severe convective weather is a prime source for wind shear and microbursts. LLWAS, Low Level Wind Shear Alert System, reports installed at 110 airports in the US designed to detect wind shifts between outlying stations and a reference centerfield station. E. Pilots. Reports of sudden airspeed changes on departure or approach and landing corridors provide real-time indication of the presence of wind shear. B. Obtaining weather information. Number 1. What is primary means of obtaining a weather briefing? The Flight Service Station (FSS) is the primary source of obtaining pre-flight briefings and in-flight weather information. The FAA provides flight service program through FSS both government and contract. There's a phone number that I'll put in the description. And via the internet through Direct User Access Terminal System (DUAT) and Lockheed Martin Flight Services. Number 2. What are some examples of other sources of weather information? A. Telephone Information Briefing Service, or TIBS. B. Weather aeronautical information available from numerous private industry sources. DUAT and Lockheed Martin Flight Services via the internet. Pilot and current medical certificate can receive pilots with current medical certificate can receive pre-flight weather data and file domestic VFR and IFR flight plans. D. In Alaska, transcribed weather broadcast, T-Web, telephone access to the T-Web and TelWeb. 3. You're planning a cross-country flight. Does the weather data provided by commercial and or third-party vendors satisfy pre-flight action required by 14 CFR 91.103? Pilots and operators should be aware that the weather service is provided by entities other than the FAA, NWS, or their contractors, such as DUAS, Lockheed Martin Flight Services, might not meet the FAA quality control standards. All operators and pilots contemplating using such services should request and or review an appropriate description of services and provide a disclosure. When in doubt, consult with an FAA flight service specialist. When in doubt, push a pull. Number 4. What types of weather briefings are available from an AFSS or FSS briefer? Standard briefing. Request when you are planning a flight and you have not received a previous flight briefing. Received a previous briefing or have not received preliminary information through mass dissemination media. Abbreviated briefing. Request when you need information to supplement mass disseminated data, update a previous briefing, or when you need only 1 or 2 items. Outlook briefing. Request whenever your proposed time or departure is 6 or more hours from the time of the briefing for planning purposes only. In-flight briefing. Request when needed to update pre-flight briefing. Number 5. What pertinent information should a weather briefing include? A. Adverse conditions. B. VFR flight not recommended. C. Synopsis. D. Current conditions. E. In-route forecast. F. Destination forecast. G. Winds aloft. H. Notices to airmen or NOTAMs. I. ATC delay. And J. Pilots may obtain the following information following from FSS briefers upon request. Information on special use airspace, SUA, and SUA related airspace, including alerts areas, MOAs, MTRs, IFRs, IFR, VFR, VR, and SR training routes, warning areas, and ATC assigned airspace. A review of the printed NOTAM publication approximate density, altitude data, information on air traffic services and rules, customs, immigration procedures, ADIZ rules, and search and rescue runway friction measurement, value NOTAM's GPS ream availability, and others as required. Oh, what a mouthful. 6. What is an HW HIWAS? Basically, hazardous in-flight weather advisory service is a continuous broadcast of in-flight weather advisories, including summarized aviation weather warnings, SIGMETs, convective SIGMETs, center weather advisories, AirMets, and urgent PIREPs. HIWAS is an additional source of hazardous weather information which makes this data available on a continuous basis. Nav aids with HIWAS capability are depicted on sectional charts with an H in the upper right corner of the identification box. Where implemented, HIWAS, it's HIWAS, so it's HIWAS, alerts are broadcast on all except emergency frequencies upon receipt by ARTCC, terminal facilities, and FSS. Number 7. What is Flight Information Services? Flight Information Service Broadcast, FSIB, is a ground broadcast service provided through Automatic Dependent Surveillance Broadcast, ADSB, service network over 978 MHz UA data link. The FAA FSIB system provides pilots and flight crews of properly equipped aircraft and flight deck display of aviation weather and aeronautical information. Can onboard data link weather FISB be useful in navigating an aircraft safely around an area of thunderstorms? Can onboard data link weather be useful in navigating an aircraft safely around an area of thunderstorms? Weather data linked from a ground weather surveillance radar system is not real-time information. It displays recent rather than current conditions. This data is typically updated every 5 minutes, but can be as much as 15 minutes old by the time it displays in the cockpit. Therefore, FIS aviation weather products are not appropriate for tactical avoidance of severe weather, such as negotiating path through hazardous weather. That makes sense. 9. While en route, how can a pilot obtain updated weather information? FS on 122.2, an appropriate ICO remote communication outlet frequencies. ATIS broadcasts along your route, your flight. That's what you hear. HIWAS, hazardous, and data link, and ATC workload permitting. ATC can give you a weather report basically if they're not overloaded. Section C. Aviation weather reports and observations. Number 1. What is a META and what are two types? A. META is an hourly service observation conditions observed at an airport. There are two types of META reports. A routine META. Hang on, let me just 1 second. This already is going to be a long ass video, so I'm just checking to see how long it's. There's like 10 more pages to go. Okay, so what I'm going to do is I'm going to pause it here. I'm gonna split chapter. I'm gonna split chapter 3 into 2 separate videos because I understand weather is pretty dry stuff, no pun intended. But stay tuned because right after this, I'm gonna give you a little bonus for sticking through this. Okay, be right back. Hey guys, so it's me. So after going through those review questions, I felt you deserve a little reward because you've come through 2 chapters already, and we're halfway through chapter 3. So I wanted to give you a practical exam or practical example. So this is what we've been reading about. This is the airport for Gabe information. These are the meta reports. These are your basic information. It gives you the airport name, the time is in Zulu, GMT basically, Greenwich Mean Time, wind knots, clear, and there's the dew point and clouds. Altimeter is 29901. RMK is the remarks, and those you don't really need to worry about. There's just special information about the airport itself. This is the cloud level and stuff like that, MOS weather forecast for the area. This is pretty simple actually to understand. I mean, it's just once you see it, it's basic. When you're not reading off a textbook like I was, it's harder compared to doing it like this. Note these are specific information about the airports or other things that you need to be aware of. Currently, there's construction going on the runway and everything like that. So during the night time, they shut down runways 06 and 24, which is that long one, until like 5 in the morning local time. And you got tons of stuff like that. And there's the list of remarks if you really want to know. It just tells you. It just tells you what the traffic patterns are going to be, or anything special, business hours like that. So when you come to do the weather, you can. The only thing that you need to worry about is up to the point where it says RM out, gives you the altimeter. After that, you don't really need the remarks. And it basically it. Then, so Allentown has both an ATIS frequency and an automated phone number that you can try. So, you normally look on tactical maps on airports and stuff like that, and it tells you if they have ASOS or ATIS. Sometimes they switch over when it's automated. So I've got my phone plugged in, so let's... Yeah, all those times I tried to call. So let's see, hopefully no one answers. It shouldn't be because it's close to midnight.
Automated weather observation 0452 Zulu. Wind calm. Visibility 7. Sky condition clear. Temperature 02 Celsius. Dew point -01 Celsius. Altimeter 299er 2. Remarks. Density altitude -1000. Lehigh Valley International Airport. Automated weather observation 0453 Zulu. Wind calm. Visibility 7. Sky
So there you go. You got updated information over the phone that's more updated that's on the information on the thing. So just like the book says, the stuff that you have on the tablets updated between 5 and 15 minutes is the latest information. The altimeter changes all the time. So they haven't even put the new one up there yet. Because it is only just changed. It changes 55 on the hour every hour, so it's about to change. We're talking to someone. But, alright, so there you go. There's your little reward for sticking through the weather. I know it's pretty dry stuff, so I wanted to give you a little bit of a bonus. I guess. Check you later.